Hey everyone, I'm Jean-Sébastien and I'm a backend engineer here at Strapi with a focus on developer experience. Today we're going to talk about how to provide a better developer experience for applications with highly dynamic content structure and TypeScript. Ready? Let's go. First of all, TypeScript is awesome. I'm sure a lot of you already heard those points again and again, so I will try to be quick. But basically, TypeScript enables, among other things, type safety, better IntelliSense, and ease of navigation through complex code bases. Regarding the type safety, we have the compile times errors and real-time linting in IDEs. Next, for the codebase exploration, we find types annotation, jump to declaration, and definition. Finally, for IntelliSense, we find the real-time guidance as we write code thanks to autocompletion and code suggestion. So TypeScript is awesome as it helps developers improve their productivity while reducing development costs by eliminating most of runtime's errors and code-based exploration struggles. However, TypeScript isn't a magical solution, and it's sometimes not as easy as just renaming JavaScript files to TypeScript. Let's understand why. See, TypeScript works very well when it comes to IntelliSense or type checking because it relies on a source of truth, which is the types defined by the developers. Developers who tends to know very well the application structures and models. Or at least they are supposed to. Someone developing an e-commerce website likely know that they will need model to represent a product, a brand, a cart, and also how to interconnect them by creating links and relation. In the same way, someone creating a blog know that they are dealing with posts, tags, and authors. In fact, TypeScript is only the referee. It reads the rules written by the developers, understands here the types and the configuration, and then emits warnings, errors, and even code. So far, so good, right? Well, as I mentioned at the beginning, I'm currently working at Strapi, where we have to deal with a very particular situation. We don't know anything precise about our user applications model. Really, we don't. Whether you want to create a blog, an online shop, or even just like a static website, well, you can use Strapi to design and automatically generate very specific models that will be unique to your application. And well, we simply cannot predict what kind of content you will want to create, nor do we want to restrict what you can do. Thus, it makes creating types for shared Strapi APIs a real challenge. Indeed, in order to connect our user application and our core functionalities, we do need to interact with the apps model, whether it's for managing content or adapting our APIs and our administration panel. For instance, let's take a look at a common situation we are dealing with on a daily basis. The goal here is to create a generic function in Strapi internals APIs that will query a given model by its UID in order to fetch its related content from the database. It's something that's quite common and both useful for Strapi core and Strapi application. If we try to write that in JavaScript, we end up with this signature. Let's now try to add some types to it, and we get this. While it's accurate from the TypeScript standpoint, it doesn't really help us much when developing our application because here we have bad loose type checking, no autocompletion for what are the available UIDs, or any information about the values that we can expect in the answer. It makes the developer experience a bit weird, and you will likely have to do a lot of casting in order to adapt the types to your app logic. To fix that, we will need to have access to some kind of TypeScript database or registry of all the models that exist in our external application as well as their UID. A bit like the following. This is where dynamic type registries comes into play. Dynamic type registries are regular interfaces declared in a shared module that will be exported by Strapi score. While being empty by default, we decided to leverage interface merging and augmentation abilities to give the possibility to other actors like a Strapi application or a Strapi plugin to add new type definition to those interfaces. For instance, if you use an article model in your Strapi application, you can then register it in the shared interface so that it can be then picked up by Strapi when using its internal API. We thus have a database of shared components, such as the models in our case, being used by internal APIs while being populated and augmented by external actors. In the end, this allows us to write generic APIs based on abstract model and entities on Strapi side, while giving the full power of TypeScript autocompletion and IntelliSense in user projects that extend the type registries. Here's the design of what we've just explained. As you can see, Strapi exposes a module of shared registries that contains a bunch of interfaces. This module and its interfaces are then extended by external actors, such as the application or a plugin, and can then be used by anyone to create custom APIs or just reference types, for instance. While this solves the problem of having precise types and developing powerful typed APIs, this is not a very scalable solution per se. Having to write complex types and augment manually many shared registries for a single application is just too much to ask. And in the end, it would only create frustration and weaken the developer experience. Type generation is the answer we found to enable dynamic typed registries at scale. It basically consists of Strapi reading your application models to generate types that will then augment the dynamic registries. First of all, we defined some needs for this. We wanted a solution that could be embedded in other piece of code. So we want something programmatic. We don't want a script. We also wanted something that can create types so precise that it can output literal types, so literal strings, numbers, and so on. And finally, we needed something maintainable. So we don't want to have to do raw string manipulation like concatenation, interpolation, that kind of things. And this is when we found out about the programmatic TypeScript factory API. This API exposes a set of utils made to create and manipulate TypeScript AST nodes. Well, we then simply took our own models, transformed them into TypeScript nodes using the factory API, created fake source file from the same definition, and then finally emitted TypeScript definition files containing the registry augmentation and the related model types. Here you can see what happens when we manually trigger type generation as it creates types for the Strapi application, content types, and components. And here we can see a part of what's being emitted. We can observe the shared module augmentation, as well as the component registry being extended with different models. In the end, we were able to find a workaround to enjoy every benefit TypeScript has to offer while dealing with highly dynamic content structure. We can see here that our previous example worked perfectly with the generated types and augmented registries. I hope you enjoyed this quick presentation on developer experience and TypeScript, and I wish you the best. Goodbye.